Welcome to section 9.5, the final section of this normal distribution chapter. In this section, we will use the previous techniques we learned from 9.1 all the way to 9.4 and use them to answer questions in context of real-life questions. Let's have a look at example 8. It says the heights of a large group of women are normally distributed with a mean of 165 centimeters and a standard deviation of 3.5 centimeters. A woman is selected at random from this group. It says find the probability that she is shorter than 160 centimeters. Now, in order to solve this using the normal distribution, we need to work out what the normal distribution is. What is the variable in this question? The variable in this question, it's actually written here, but you should be able to work this out from the question itself. It's the heights of a large group of women. It's not the number of women in the group or the weights of the women. It's the heights of the group of women. Now, heights is a random continuous variable, so it does make sense for it to be normally distributed. So, and it's normally distributed with a mean value of 165 and a standard deviation of 3.5 centimeters. It's the heights, that's the variable. Find the probability that she is shorter than 160 centimeters. Let's first write that down in terms of probability. Probability that the height is less than 160. Let's first standardize this. So probability of z being less than 160, take away the mean, 165, divided by the standard deviation of 3.5. This is equal to probability of z being less than minus 5 over 3.5. If we sketch this on the graph, we have a negative number, minus 5 over 3.5, and we want the z less than that, so it's the probability to the left of this value. So we're going to have to use a symmetry to reflect. So reflect, I'm changing the sign to 5 over 3.5. So it's what we're getting is this scenario here. We are going to have to use the 1 minus method to make it less than positive form. So z less than 5 over 3.5. Now this is equal, let's work out 5 over 3.5. This is 1.43 to 2 decimal places. So if we look this up on the table, so again, so this is 1.43. The corresponding probability is 0.9236. 1 minus 0.9236. And this is 0.0764. So that's how we do the first question. And then on to the second question. It says boxes of chocolates are produced with a mean weight of 510 grams. Quality control checks show that 1% of the boxes are rejected because their weight is less than 485 grams. And the question is, find the standard deviation of the weight of a box of chocolates. Now this is a chapter 9 question, so we're going to have to somehow use the normal distribution, but in this question it doesn't say anything about normal distribution. Now this is a kind of scenario where we'll have to use the statistical judgment. The weight of the boxes, like the heights of the women, are type of things that are normally distributed by nature. So our variable let W be the weight of a box. So that's going to be our random continuous variable. Weight is a continuous variable. And it says the mean is 510 grams, so that gives us one information. And it also says that 1% of the boxes are rejected because their weight is less than 485 grams. Now, how can we translate this to something that would help us? Well, the probability of the W weight being less than 485 grams is equal to 0.01, because 1% of the boxes are less than 485 grams. So from this we can work out sigma, which is the question. So let's standardize this. Probability of Z being less than 485, take away mu, which is actually given 510, over this unknown value sigma is equal to 0.01. And this means that probability of Z less than minus 25 over sigma is equal to 0.01. Let's draw the graph. Z being less than this negative number is 0.01 because it's a small probability. So it's a less than negative form. So let's flip it using the symmetry, 25 over sigma, and that's going to give us the same area, 0.01. Now this is in a bigger than positive form, but it's a nice percentage, so we can use the percentage table, and the 0.01's corresponding Z value is 2.3263. So 2.3263 is equal to 25 over sigma, and this means that sigma is equal to 25 over 2.3263, which means that sigma is equal to 10.7 to three significant figures. Okay. And then finally it says, hence find the proportion of boxes that weigh more than 525 grams. So let's write that using probability. It says to work out the probability, proportion and the probability are basically the same thing, of the weight of the box being more than 525 grams. How do we do this? Now we know the mean and the standard deviation. Let's save this. I'm sure we're going to be using this later. So let's standardize it as always. Z being bigger than 525, take away the mean, 510, over the sigma. We now know what it is, but instead of writing 10.7 every time, let's just keep it as sigma for now. This is probability of Z being bigger than 15 over sigma, and if we sketch the graph, 15 over sigma, sigma is again always a positive number, so it's the positive area to the right that we want to find. So let's use 1 minus method to make it less than positive form. And then finally we can look this up on the table. 15 over sigma is equal to 1.40 to 2 decimal place. So the value we want is 0.9192. 0.9192, and this is equal to 0.0808, and this is the probability. So the main thing we learned today that you should be able to take away is that things like weight and height are things that are naturally normally distributed. You also need to be able to translate things which are not directly said to be probability as a probability form. And you need to be able to pick out the key facts about the mean and the standard deviation, and also work out what the variable is in question. Okay, so this ends the video for this chapter. Thank you for watching.